Good day, and welcome to another episode of Agent X11 Hollywood Dark Journalist. Another light in this darkened world. I am your host, Penny L.A. Shepherd, and I am Agent X11. My co-hosts are David Zublik, Heather Day, Joan Renee, Chris Montgomery, Skip Press, Tom Althouse, Jessica Garza, Edward Medallion, Dr. Keith Abloh, and TJ Ward.
Good evening, ladies and gentlemen. We are tonight's entertainment.
Agent X11 Hollywood Dark Journalist begins now. And welcome to another episode of Agent X11 Hollywood Dark Journalist. And this is a new segment that we're doing concurrent with Brian Singh, who has joined us. And it is called Dr. Yu's Universe. We're premiering it today, and we have him on our Friday show. And he will be running opposite Brian Singh. And my name is Penny L.A. Shepherd. I am Agent X11. I am joined by my two co-hosts. And Tom, I'm putting you in the middle. It's just the thing I do. It's the boy girl thing. And my co-host Tom Althouse and Joan Renee. And then we have Brian Singh, who has his own segment. And then we're joined by Dr. Yu and by Steven Sanchez. Tom, how are you?
I'm doing really well. I'm excited for this premiere. Let's do it.
Yes, it's very cool. And Joan Renee, how are you?
I'm actually pretty good. Hey, Dr.
Getting up
Yu.
at 1 a.m.
Yeah.
And Brian, how are you? I haven't seen you in a while.
I'm good. I just got back from Las Vegas for the Alien event expo, Biomed Expo, run by David Said Farman, and a lot of great people together. Working on disclosure. And so I'm now in the process of relocating here to Sedona, Arizona, where we're going to be opening up a new research center and institute.
Yes, and I know some people that will be joining you there. I'm not sure who they might be, but no disclosure. And Dr. Yu, how are you?
I'm very well. Thank you for having me on.
Thank you.
I'm happy to meet the new people. If you can put the name back.
Oh, the names. Okay, yeah.
Yes, so
I'm
that would
sorry,
be
so that you
easier.
know who everyone is.
Yes.
That's a little thing David did. There we go. How's that?
Yes, thank you so much.
Thank you, color. And then Steven Sanchez, how are you?
Oh, I'm doing good. It's a lot of fun doing a lot of the cool stuff that I do. And yeah, it's all good.
All right. So now we have a PowerPoint that we started on where we're talking about.
Oh, Penny,
Yes.
I just send you an email
Mhm.
with my PowerPoint, the real PowerPoint
Okay.
format. It has a video embedded. If you
Okay.
can download it, that one, so I can just if you show the next page, I can just start it the next page, and then you can download it
Okay.
whenever
I will
you're
be doing
ready.
that, but unfortunately, if there are videos that are embedded in there, I can't actually play them. I can play them through here. I can try to, but I generally separate the videos from the PowerPoint. So I
Oh,
will go ahead and download that. Well,
oh,
let's give them a quick review of that, and then I will
sure,
download that while we're talking.
yeah. So, do you want me to start it or?
Yes.
Yeah, please, Doctor. What are
Yeah.
we looking at here? I
Oh,
see the charged particles and photons. What is a muon?
oh, okay. Yes. So happy to see you, Thomas, and also Brian. I just wanted to give you a brief review of this chart, and then we can start it. Continue with the from the last time we left off, like a full chart later. The key point. So I summarized all the discoveries in this new theory in 3 key points. So just in case somebody have to leave earlier, so you know what's the major discovery or findings there. The first one is called a monocharged particle. So which I defined as any particles has either negative charge or carry positive charge as a separate particle. So I call it a monocharge, single charged particle. Uh, have you ever heard of this called a monocharged particle term, Thomas or Brian?
I have not.
Oh, you haven't.
Yeah, I mean, yeah, I definitely heard of electrons and protons,
Yeah, like
and
Yes, yes.
neutrons
Uh,
from biochemistry.
oh, okay. That's fine. I believe Thomas heard of these particles before, but its terminology say monocharged particle. I defined any particle carry either positive or negative charge. So I call the monocharged particle. What's the significance of the discovery is all these charged particle that's defined by called the standard model of particle physics. So that's basically the quantum mechanics model. If you look at the far right, the stamp I put there, all these quantum mechanics model do not exist. So you know what that imply, right? Imply the entire quantum mechanics model is a bogus model, right? But where this problem started, so that's where I try to start it. Number one discovery is though called the electron carry negative charge, or positron or proton carry positive charge. So since you studied the chemistry, right, and that works, they cannot
Yeah,
exist.
that's why I learned quantum jumping and electron
Exactly.
orbitals and octets.
That's the word quantum derived, right? It can jump. You cannot
from
jump
levels.
continuously. You cannot jump in any mass. You have to have a
Either
lump
or.
certain mass, right?
Mhm.
And jump from one orbit, or called the shear principal axis, from one to another one, right? That's quantum jump. The weirdness is this jump cannot be continuous. So it cannot jump, say, from this orbit, deviate through time, continuous to time to the other one. Cannot go through time, cannot be continuous with space. It has to disappear. So that's what quantum weirdness, right? The jump of electron from one orbit to another orbit, you cannot gradually. If you gradually, entire quantum mechanics model will be broke out. Broke out. It's not cannot exist. It has to be fixed there.
Dr. Yu?
Yes. Oh, yeah.
Just to bring Tom up to speed so that he understands what we're talking about here.
Oh, okay.
What we're doing is we're taking the atom model. We're assuming that that's just a theory and it doesn't really exist, but everything is made of a positive and negative charge. So every so that's where you get the positive charge and the negative charge. And as they come together in different ways, that's basically what matter is made of.
Right.
But it's just that's all really that there is. And so that's where the UON comes from. And that is why Dr. Yu is now talking about this quantum theory and the jumping the atom theory can't do that, but
cannot do that one.
Well, I think I misled you all. I've actually been studying quantum physics, and I've come up with some ideas that are missing ideas, and I've been coming up with the idea. I've never shared it yet, but things find balance, and what you're explaining, Dr. Yu, makes sense because it's going to find balance. It's not going to be in a chaos time all the time. It's going to find a balance. If you got a rock on a hill, it's going to roll down if there's gravity. It's not going to go back and forth. It's going to find a balance where it fits most in congruency with other things around it. So I have a lot of problems with Einstein's spooky equation thing because it seems like the experiments they did weren't thorough. And it's like when they did the thing through the cards and it appears in two different places that it seems like it's frozen in time. Well, there's a lot of things I've been thinking about as I study quantum physics where they missed the boat on going further. So I'm very excited to hear what you have to say now more. So it's like, yeah.
Dr. Yu, can you explain to us? So what is if we're ditching the electron proton model, charged particles? Then what can you explain? What is your conceptualization of the physics?
Okay, wonderful. Comes to Tom's first question. Say what UON is. So after I discover the monocharged particle, basically that's all the quantum mechanical particle cannot exist. That's the mass particle, and also the quantum mechanics called the force carriers, a photon, right?
Because most of the mass, according to modern quantum physics, is in the electrons and the protons.
That's right. Yeah, these are mass carrier, but I find that photon cannot exist either. Photon defined as a particle of light. So now the question is, what is the real particle? Fundamental particle make up the universe. That's what I defined as a UON, called a universal fundamental particle. U means universal, particle use on, so UON means universal fundamental particles. And simply just say it's a dipolar magnet, just magnetic particles. And in this discovery, I found that magnetic particles is the only particle, not only it's a fundamental, and it's the only particle can exist, beings can be seen, can be feel, can make the entire universe manifestation.
So are you saying instead of protons and electrons as charge carriers and photons as force carriers, instead it's all these UONs that
means the particle carry both positive and
negative charge
in one particle. So you see, my contrast is monocharged particle can only carry single charge, cannot exist. Everything has to be dipole. Yeah.
So if it's dipolar, then it carries its own mass and force.
Yes. Penny, I'm gonna try to get the link to you.
I'm trying to access it. It's very I can't access it. I was trying to
Brian.
You have to give permission. If you give me permission to access it to
and you can just send it directly to my phone. I'll send it to Brian.
Yeah, and I requested access via Google Drive. So if you go into your Google,
I'm in my Google Drive. I have your email. Google
EphesiansB@gmail.com. EPH. Ephesians.
I add another one. Okay, just
the other one is mine. Shepherd Entertainment.
Oh my goodness! How to add another one?
I might have sent a request, so it might be in your Gmail.
Yeah. Yes. If you, so I'm gonna. I saw that I have this viewer. I have you as the editor. Why? Penny,
just a view it. You don't need to edit it.
Okay. Are you able to download? I sent another link. I'm so bad at this kind of modern technology. But anyway,
don't feel bad.
Okay, don't feel bad. So, Penny, you see the second link. I hope you can download it, and I'm gonna just start with keep going. So you are just universal.
Either that, or do you know how to share your own screen, Doctor?
Oh, you can do that one.
Why
Sure.
don't you share? Why don't you share your screen and pull up what you want to show us?
Oh, share my screen. Use a presenter share or
yes. So you just hit the plus sign.
Okay.
At
yes.
the bottom.
Yes.
And then you go to present.
Slides. The problem is it says I cannot. Share screen.
Yep, share screen, and then you choose the screen. You're going to hit entire screen.
Entire screen. Okay.
And then from entire screen, now you can share whatever you want to share.
And then Penny will pull it up. She'll pull it up so we can all see it.
Okay. So do you see anything? I use
Not
the
yet.
share.
You have to present.
You have to click on it. You have to click on it and hit present.
Say share screen.
Oh,
and you have
present.
To click, yes, click on the screen you want to present and hit present.
Oh, this is the PowerPoint. You do not see it. So yes,
You have to click on share screen. Then when you click on share screen, you select that PowerPoint. So you can either say window or entire screen.
Okay. I said share screen. Stop.
And then it says select. It'll say
that PowerPoint.
Then it'll say once you hit share screen, then a pop-up will appear. It says select window or screen. Then you have to pick either Messenger, StreamYard, entire screen.
Oh my goodness. Okay. So I already shared, but somehow do not. So control. I have a voice.
Yeah.
I have.
If you have your PowerPoint open on that screen, you should see it.
So this is my PowerPoint.
Are you able to see? Open your PowerPoint on the screen and then go share screen and you'll see it.
Let's see.
Or Doctor, you have this. I'm going to put in the group chat
okay.
my email, and if you want to email it to me.
Okay, share screen.
And then in the meantime, why don't you just, without using any, it's taking too long. Why don't you just describe what you're trying to tell us?
Thank you, Brian.
It was a good effort.
Yeah.
Is that there? No, still not. I click the share entire screen and click the share, and still nothing show up. Right? So, okay, maybe Penny, you just go through with your slides. That's it. So next time I will learn better.
Yeah, Penny, why don't you pull up the slides?
Yeah.
Give me a second. I'm still trying to download. This is why I do everything before the show, because it.
Oh yes.
Well, the other thing is, Dr. Yu, are you able to go in your? There you go. And you can always grant me access. I send you access requests.
Oh, okay. If you send me access,
I did. And then off of that, I should be able to play it on my computer and share screen.
Oh, access. I do not see your screen.
Go to your Gmail. Open up your Gmail, and in your Gmail, you'll get an email saying Brian Feng is requested to view this document, and you have to grant access.
I do not have a Gmail, but I have a Yahoo Mail. Okay, Brian. Yes. Okay, I see that one. Okay, so I just managing share.
Yes.
Okay.
And then you want to grant me access.
Grant you. It says download, open, connect. Is that a connect access?
Yes.
When is a download? When is a connect? Okay.
Sure. I both. Whatever.
See all. Okay, I will see all. Oh no. Oh, I'm so bad at this.
Don't feel bad. I was
okay.
So
the same way.
I saw that.
This presentation will include how to share a Google Doc.
Yes, that's I got lost.
It's fine. Let's just go with what we have already then for the slideshow.
We'll go with what Penny has, and we'll go through what you have, and then you can add to it next time, and we'll be able to see the video.
Sure.
So Yeah, just as long as you can grant me access for next time, I'll have everything ready for you.
So this will be a preempt. It'll be a preliminary.
Correct.
Okay. So sorry about that. Actually, that's fine. You know, Penny, if you just go down to next page and let's see if they have any questions. This is talking about where the fundamental problems happens. Since Tom and Brian, you both have apparently you have experience. So I would say actually the problem started 241 years ago. In 1784. It's now the start. Most of the people would think about it started with quantum mechanics relativity, but in my discovery, it actually started way before that one. And what's the problem with those? This is one of the most fundamental law in electrodynamics, electro theory, right? So basically say like pole repel. However, this law implies, so that's called the premise, implies, so that Coulomb law, if you read the bottom line, it's called presuppose existence. It is assume existence of monocharged particle. Basically, negative charge by one particle, positive charge by another particle. So that's what I call the problem. And then in the following slides, I try to prove why this particle cannot exist in this universe. That's we spend most of the time last hour and a half to talking about it. So if we can go to next page. Okay. So this is the video. So from the Coulomb's time, he just implied, does not explicitly say we have a monocharged particle. No problem with that one. However, this concept of negative charged electron was enforced by called J.J. Thomson discovery the electron in 1897. So the end of 19th century. Just almost the beginning of the 20th century now. So what's the problem with this one? J.J. Thomson, based on this video, this is the video I was trying to show you guys. This video basically show that's the cathode ray tube, okay? It basically is assuming if we have two different voltage differentials, and then we create a line of the light, and then what the experiment they said that they use magnets to interact with the line. Actually, amazingly, if you use one direction, if you look at the magnets, one direction go there, you see the light bending different direction. And if you rotate the magnets, and then the line bending downward. So that means, Penny, sorry. Yeah. Oh, okay. Can you send me send it to your phone? Oh,
right. Next time. Let's just continue right now.
Okay.
So then with the magnets, so it's implying that there's the magnetic force interacts with the electrostatic force.
That's what assumption is. Magnetic interact with static electricity, right? Static. Mm-hmm. The problem is what I discovered. This event is entirely a magnetic interaction event. So if you see the light, the assumption in this experiment is you have an electron ejected from a cathode from the left-hand side and traveling to the positive side, okay, and then go through the circles. So the assumption is that there's an electron as a particle traveling there. So what I find is there is no particle whatsoever traveling in this case. So the line is actually ionized, called the inert gas. In this so-called vacuum tube, we do have some kind of light gas. The inert gas.
So what you're saying is the charge isn't being carried because electrons are being emitted from the cathode to the anode. What's happening is the actual molecules inside that tube
it's already existing.
They're being excited in a way that it creates the light. but it's ionizing the actual particles as opposed to electrons being shot.
Yes. See, I think you already have this idea. So what that means, oh my goodness, Penny, I'm so impressed with your guess. Okay. So basically he already understands. So instead of something traveling, basically the ionized gas form a beam of magnetic particles. It's a magnetic particle form a beam of them. So that's why you use magnets. It interacts. So the beam bending upward or backward depends on the north and the south of the magnets. So
because what you're saying is if conventional physics was right, magnets would not affect the path. But because magnets affect the path, conventional physics is wrong, and you're assigning the force to a different phenomenon.
Great explanation.
Yes.
Before you came, I want a June to explain my thoughts. Now we have another gentleman. Yes. So your explanation will help audience to understand greatly, and your words very precisely. So you know the mischaracterization of this experiment is twofold. One is assuming electricity is flow of electron, right? Electron flow. So assuming the line is formed of a flow of particles, that's wrong. Another thing is they assuming these lines are negative charged particle. Even though you're changing magnets, they're bending different, but they still think about this as a negative charge. So actually they are magnetic particle interacting with magnets. Okay. I think you guys already understand. So now let's go further. So what I just demonstrated is, so this experiment basically just demonstrated the mistaken by J.J. Thomson define electron as a negative charged particle. From there, you know what happens. From there, we have somebody discover positive charged particle. So that's, hey, we have a positron now. And somebody say, hey, we have a neutron. It's a neutral particle because they use this magnet. They use a similar device. Can bending upward and downward depends on, say, hey, if we negative charge bending upward, if we have a particle go through this one, okay, bending downward, they say, oh, this is a positive charge. And if we have a particle traveling straight line, this is a neutral particle. So based on, because of J.J. Thomson named the electron as a negative particle, then the error, this is a fundamental error, okay? And what is called a cascaded to, we have a positron, we have a neutron, and we have a atomic called orbital type. This is called, perpetual motion type of atoms. So that means the electron orbited the center of the nucleus. These are, none of them exist. So what I find, atom is just like a group of static magnetic particle. It's a composite particle. Of course, you could have the particle could have a vibration locally. Each individual particle vibrate. However, entire atom is a static group of called the composite magnetic particles.
So Dr. Yu, this is a very different conceptualization in that instead of from the charged particles, positive and negative, you're now going towards a much more magnetic conceptualization of the physics. Then how does this fit into the thunderbolts, the electric universe understanding? Is that what this is? This what you're leading to? Your physics?
No, exactly opposite. Thunderbolts, assuming everything is electric.
And you're saying everything's magnetic.
I would say electric arise from magnetic. That's
so magnetic is a primary force here.
Magnetic is a primary force.
So I have a question, Dr. Yu, with quantum tunneling. Is this, yes, that's why this is an error, right? Quantum tunneling isn't true.
It is an error. It is a so-called, there's a quantum particle, somehow can go through the barrier. Right?
So I wanted, can I interrupt for just a little bit? Because there will be a lot in the audience that might get lost when you're talking about quantum tunneling. So can we explain what that is and then go on to talk how this applies?
Tom, can you use your language to explain tunneling, and I will add anything.
I would say, I hope I get this right in common tongue, but it's like they were trying to explain why particles were traveling through barriers, and they couldn't come up with an explanation. And they made it like they're ghost-like. And they, on these programs, they'll show a big ball just passing spookily through a castle wall, you know. And it's like they'll say it's quantum tunneling, and it's like it never made sense to me, because it's like, how can it just? It sounds like a shortcut, like a drunk person saying, "Well, it just made it." You know, it's like they're not explaining how or why. So we're back to that spooky element again. So I say quantum tunneling is just an excuse for how something that should not be able to pass through just passes through.
Very good explanation. That's you are explaining. That's what the traditional, or the modern physics explain quantum tunneling, overcome the barrier, and traveling. What I found is there's no actually. It's all wave motion. There is no physical crossing any barrier.
Yeah, you might as well call it the Santa Claus particle, and it just comes down the chimney.
and basically, whether that barrier was there or not, then the particles would end up in that other, quote unquote, other side. Barrier or no barrier, the particles end up there because of the waveform nature, as opposed to the fact that there was a barrier there and there's a probability issue.
Can I bring up the biggest thing that bothers me the most about quantum physics for you, Dr. Yu?
Go ahead.
Totally turned me off is the idea that there is a negative for every positive of ourselves, and if we come together, we'll no longer exist. Can you address that? It's like they're talking about how everything has a negative, everything has a positive, and then our universe, we are all negatives, and there's a positive version of our universe, and if it ever met, the negative and positive will cancel each other out.
Oh, okay. You are talking about, say, basically, we're talking about matter, antimatter, right?
Yes,
the Big Bang.
Yes, the Star Trek.
Basically, they try to explain where comes this universe. So, and the Big Bang theory, assuming, hey, the universe before Big Bang, there's no space, no time, no matter. This, of course, is nonsense. Okay, but let's just go ahead with their assumption. So they said that if there's nothing, everything started with the Big Bang. We know nothing. Nobody can explain what is a second before Big Bang, right? So let's just start it with the Big Bang. So say how Big Bang can create a matter. So how could you create something from nothing? So that's where, okay, Steve, so you can kick in anytime. So that's where they said, hey, if we have a matter, because we know a human being exists, right? We know have a matter. So they said that in order to create something from nothing, you have to have a mass, just like you said, like a positive, just as a mass, or negative. We're talking about that, just say called antimatter. That's totally ridiculous. Yeah. I agree with you. So and how do you get back and say, hey, if you can create something from nothing, can you make something to disappear, become nothing? So that's where annihilation comes from. So if matter and antimatter come totally annihilated, means becomes energy and no mass. There's a conservation mass. Conservation actually no longer exists. Nothing exists.
I have trouble too with the idea of nothing and the Big Bang, where this force comes from nothing and is still propelling the universe out at enormous rates. It just seems like, what? One singular event and you still have this energy? We need to harness that for the perpetual engine. I mean, it's like, how do you get that? It doesn't make sense. And
crazy.
Steve wants to answer that.
The problem is because we're two-dimensional being avatars trying to conceptualize everything by quantity, quantum, physicality, and absurd. Nothing has to be nothing, right? Because all we have is this perception of something. You have to understand nothing before you can understand something. So here's a question for you. Wave propagation. How can that happen in a vacuum? I can actually explain how that can happen. Because you got space and you have counter space. Counter space is immutable. You can go anywhere, anyway, have infinite amounts of energy potential. But how does that work with this model? Something has to move from emptiness into reality and back and forth. Kind of like Maxwell equations. It's quadratic. So think about this, your muon, and I've been sitting here writing. Think of it as a bipolar coherent geometric oscillation. Oscillation of what? Counter space. This counter space gets motion and vibration, and you give it precession geometrically, you get a thing called a solid. Now, guess what? It's immutable. You can go from space into counter space and backwards and forwards. Take a sphere or take a toroid. You got an outside infinite surface. You have an inside infinite surface. That is the condition or boundary condition of moving from space to counter space. What created that boundary, what we call physicality, is that space where coherency and incoherency presides and resides in non-matter and real matter. By its precession, by its movement, by its rotation, denotes different types and shapes and forms of matter, which coherently I can use scalar propagation and make something appear here and go on the other end of the universe and appear there, because in non-propagated, incoherent, non-matter, whatever you want to call it, emptiness, there is no dimension, which means you can go dimensionally anywhere instantaneously. So what is moving in and out, that is what's going on. A particle would be a coherent structure geometrically moving so fast, it looks solid. And guess what? Because it has precession, it has bipolarity, it has magnetic potential, depending on its precession, depending on its magnitude. And guess what? It's scalar, it's holographic. It can be infinitely small and infinitely large. It's all the same. One mirrors it inside and out, wheels within wheels within wheels. That's my way. That's my take on it.
Can I just jump in and really make it simple as almost kindergarten simple?
Good.
Let's assume that all matter is created by harmony, and that wave, that harmonic waves, actually are what the negative and positive is made up of, which means that really in reality, if the symphony stopped, there would be everything would fall apart. But basically this whole universe is a symphony, because everything exists because there's vibration, there's motion, and like, for instance, we have a singer here, Penny. When there's disharmony, everything goes. So if you want
like disharmony,
if you want to create a destructive electrical charge, you would create disharmony. And through the creation of that disharmony was where you get things that explode. That's where you get the lightning. That's where you get these charges. So am I interpreting this right?
My theory slightly different. So let me explain my perspective. But I believe you explain, Stephen's idea probably perfect. Okay, so let him to answer that one. So I just want to say Thomas and Brian to know what my interpretation of the matter. So matter and the space and the time exist eternally, no beginning and no end. So space basically is a container, empty container. In order for anything to happen inside of space, which is eternal, no beginning, no end, okay? In order for everything happening, it has to have a matter happening inside. In order to describe the change or the existence of a matter interaction, you need a dimension of time. So if space is infinite, ever existed, so time will be ever existed too. In order for matter, instead of the matter being created by, say, a super being or something, in my theory, I assuming besides invoker of a religious god or something, I would say matter are conservative. That means cannot be created and cannot be destroyed. existed eternally. Does that make any sense to you? At least my concept is clear to you.
Well, it's almost like you're saying then in that conceptualization, if you can't destroy or create matter, well then when we look at the Big Bang, instead of saying there's nothing before the Big Bang, there was something, and then it got reconfigured to what we know now. But that's not to say there was nothing into something.
Excellent explanation. Oh my God.
Can you, can you give me an alternative to the Big Bang? Because I'm so frustrated with the Big Bang Theory.
Right.
In fact, being a singular event seems dumb. If it was like a Big Bang actually existed, why would it be a singular event? Wouldn't it be like an engine sputtering or something where it like boom, 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 you start out? Why would it be a singular event? Everything's so simplified. So what would you use as a model for our universe?
Big Bang never existed. It's a human misinterpretation. Thank you, Steve.
Simplistic one, a very simplistic one.
Yeah, and the reason we come after the Big Bang, so you can see, is basically what is Hubble. Hubble, Hubble discovered the physics. Hubble discovery, accelerating expansion of a universe.
Yeah, because Hubble is saying there's a theoretical beginning point, and then everything expanded from that center. And then the Hubble is looking outwards. It can kind of track the boundaries and then try to reverse back in to find what would be the starting point. But what you're saying is, if there's no Big Bang, then there's no starting point. But then if there's no starting point, how come the Hubble is conceptualizing space expanding from a central point?
Yeah, that's a mistake made by Hubble. Okay, Hubble thought he observed, seems like all the light, the red shift,
spreading receding. Out.
The light is receding, interpreted as a universe expands. Okay. However, and he said that he observed the further distance, the farther seems like expanding faster, right? So
yeah, the shift.
So if you believe this is true, then you can say, hey, if expand, then you reverse the course.
There's a center.
To the single point, right? So that's where logically that's what Hubble think. But now latest observation, the universe is not expanding whatsoever. The so-called expanding. So yes, we do observe a cluster galaxies. It's not just galaxies. Could have millions of billions of galaxies form a cluster galaxy. Do traveling, but not always traveling far away from each other. We do observe there is a plate in the. I believe there's one video. I may have that.
And they attribute that to dark matter, then, right? Where they say, "Oh, it's not uniform expansion, so we're going to equate that to unaccounted for mass."
You the dark matter counted that one, right?
Yeah. Right. They're using afterglows too, like the afterglow theory, that they're saying that, look, this light is faded, it's faded, it's obviously this is from the Big Bang, it's still expanding, going out. They're not. Right. There could be many reasons for this visual afterglow effect.
Yes.
And they're going to tag it this and settle it. And it's like scientists playing in a sandbox. It's Lord of the Flies. They all come to an agreement, and then that's it. You close the book. You're not allowed to play in the swing set anymore. It's like they just shut down intellectual thought.
That's the mistake. Yes, actually. Yeah, go ahead, Steve.
Yeah, one thought to consider: we're these little avatars. What do? We are born and we die, right? We can't conceive or concept anything that could be infinite. Everything starts and everything has an ending. So therefore, we're trying to run our physics the same way. God, there's got to be a start. There's got to be a big bang. There's got to be a big end. I talked to a shaman about this, and he said, you know what? The Big Bang Theory is hogwash. Beginning and endings continuously happening all the time. There was never an ending. There was never a beginning. There's a transition from space to counter space that happens at such magnitude and in such infinite ways. Yeah, good luck trying to find the beginning and the end of that, because it's perpetual.
You're going to encourage a lot of people what you're saying right here, especially scientists, because I got a call from a NASA scientist after a program where I was talking about my screenplay, and he was like, oh my God, you wrote that? Like, you're a rocket scientist. He's like, his big fear was that they were going to find the answers to everything, because everything's so simplified, that they were going to find the answers to everything and there'd be nothing more to live for, to search for. I'm like, that's never going to happen. It's always going to be dynamic. It's always going to be changing. And so don't worry about that. There'll be plenty beyond lifetimes and lifetimes.
Yeah, I mean, it even supports the black hole, white hole theory. You know, I mean, if you really think about it, space, counter space, it moves from that boundary condition of oscillation, the first movement of things, to something. And guess what? If you stop it, it goes back into itself. But I don't, because balance is implied, look at the whole universe. This process of going into space and counter space is happening mutually everywhere, because the whole universe has to keep equilibrium.
Maybe a better conceptualization than where you're coming from, Stephen, is instead of there's nothing and then there's suddenly a big bang, the idea is that there's higher levels of reality, and then we're getting a higher level of reality tunneling down to form this level of reality. Therefore, it's not something from nothing, it's something from something else, but that something else is at a different level and place than where we are now.
I believe there's only one dimension, because us as human beings, as avatars, we have these perception things like sight and seeing. They're very limited. We don't see far infrared. We don't see ultraviolet. We don't hear infrasound or ultrasound. We are only measuring this universe and trying to define it from a limited skill set. Everything is here, but until we become an omnidirectional, multifaceted, open-minded being, we'll realize it's only one dimension, and it's forever moving from space to counter space by intelligence.
Many geniuses, many free thinkers and visionaries are not speaking up because our system shuts us down. So we're holding on to our theories privately. I have one I shared at Brian's great conference, and it was like what he's just referring to right now. And it's like, I really believe it totally, but I'm not going to push it on anyone. I'm certainly not going to bring it to the scientific community. But I'm hearing now they're talking about this very thing, that there's a possibility that we were a seeded universe, to be a balanced universe by benevolence, that we're above us, a dimension up. And it's very possible that we were an experiment. We were seeded, and it wasn't a big bang. It was a very calculated thing where they created something that's balanced, and we live in it. We're the children of the product of that. But you're not allowed to say that because we're supposed to talk about God. So it's like, we're not allowed to talk about anything. Religion and science shuts us all down on our theories. So we're probably going through life with pockets of information that we don't get to share because of the very climate of the scientific community.
Yeah, I just want to give you the latest evidence, biggest evidence say the expanding of universe is not true. You know, the Big Bang may be not true. One is in what is in 2014. So there's a Nature one article, one group of scientists and college professors and scientists, they discover there is a great attraction point in space. So it's not everything just expanding. They do largely lots of it, but they discover there is a great attraction point. Eventually, everything coming back from that basically is cycling. That's exactly what is a magnetic universe. Magnets can create this called what is a rotation, right? Cycling event, curved event. So that's basically, so this is a huge evidence. They observed called 8,000 galaxy cluster galaxies. So that's not just galaxy, cluster galaxies, and find that universe is not always expansive. They have a one called the great attraction point. Everything coming back. So this is only covered as like 2014 or 2013. This is one evidence. Another evidence is we call the what is called cosmic microwave background. Have you heard of the term? Basically, they try to say, if everything started the Big Bang, expanding, so you would not have a uniform universe. So you would have some point, some places are higher density, and the other places will have a less density because the universe has a expanding too, right? If we look at the 360 degrees, we look at it, and observe the results, it's all uniform. The difference is totally negligible. So you mean the Big Bang, if you based on the evidence say, hey, how can you have a uniform distribution if you look at every single direction, observable direction, and eventually you find it's all all homogeneous, all uniform. So that's another one to say, hey, the so-called so Big Bang event may not be true.
So basically, going back to a really fundamental level of what you're saying is it's a bang or an explosion of itself,
right,
is destructive, and so that doesn't that's not compatible with the structure of the universe, because it has balance, it has structure, and if you started out with a bang, you would not have that.
Right. If you started with a bang, you would have started with zero, nothing, to something.
Mm-hmm.
So my theory is assuming the space and time exists forever. It's not the start of the Big Bang, and then the matter in it is also started exist forever. However, they can change the form, right? Change the state of the matter. And I add one more thing to the matter. Not only matter exists forever, and the matter has to be not only have a mass, it has to have a magnetism. So that's where my theory is different than called the ancient Greeks. Atoms. The atoms is a rigid matter, right? Rigid particle or something without touching. It has any property like a magnetic property or electric property, like all assuming a neutral matter. Then I find that cannot be true. So what I find is all matter has to be magnetic particle, made by magnetic particle, magnetic matter.
I have a question for you. Go ahead, Jim. Go, Jim.
Just for food for thought, is it possible that the coming together of the positive and the negative is part of what creates the matter?
Matter. In my theory is when you have a matter, you have a magnetism. You cannot separate them.
You can't separate them, but
you cannot separate.
But you can't have matter unless you have both.
Yes, exactly.
Okay. And go ahead, Brian. Sorry to interrupt.
Oh, I had a question though. I was going to say this residual thermal radiation that they claim, that is the afterglows. I want to go back real quick to this. 13.8 billion years, they're saying. Doesn't radiation have a lifespan in a sense where it breaks down, or in space it's not?
That's a good question. So basically, you're challenging if the universe, the age of universe based on Big Bang is 13.8 billion years, right? So of course that's not. In my theory, it's forever existing, right?
And so, do you think it's older? You think the universe is older than what they're saying by far?
The universe has no beginning, no ending. It exists forever.
Okay, so then the background radiation, you can see it, observe it, but don't attribute it to necessarily the Big Bang.
Right.
Try to measure backwards from that.
Yes, the background matter. That's what I call the medium. It's a light transmitting medium. If we define light, eventually I have a proof here. So light is a wave. In order you have a wave means, Stephen mentioned about a vibration oscillation, right? So what I find is if you're talking about a vibration, in order for something to vibrate, you have to have a mass and a spring. So that's called the elastic system. It can create a vibration. That's called a wave motion.
To propagate, you need a medium to propagate.
Yeah. And where comes this vibration is a particle in the medium. The particle in the medium vibrating, so created as a wave.
But what is that? That's particles, the energy. Where is that energy coming from?
To make that's a good question.
It's vibrating, that implies energy.
Yeah. So where does energy come from? Did you see stars, galaxies? You know what star means? It's constant thermonuclear explosion. Right?
So you're saying the emanations from the stars and the things in space is causing
stars explosion. That means create a light.
So that's where the radiation is coming from. So you're
that's
saying
where radiation is. Okay. I wanted to make sure the radiation two terms. There's a two type of definition radiation. One is radiation. We're talking about the light, electricity. This radiation, no particle emitted. This radiation is a purely vibration of the medium.
It's like a propagation of a wave.
Yes, wave.
All right, let me get here. Go ahead.
Well, the second one, where eject particles, those kind of radiation is totally different. Yeah.
Okay, so that's ejected particles versus a propagated wave. Well then I wanted to ask you, Dr. Yu, in terms of Coulomb's law, because even though the equation itself might be getting something wrong, the equation itself still serves. It works, right? It still has a modeling effect. So even if it's like a broken clock, it's wrong. I mean, it's not right because of the way we think it's right, but it's right every now and then.
Yes.
But in the case of Coulomb's equation, it seems like it holds pretty true. Then how do you
like charge repel, opposite charge attract? That's part hold true. Yes.
Okay, that's true. So you see Coulomb's law is true, but the conceptualization behind why it works is wrong.
Presuppose a precondition implies these are carried by two type of a particle. Very subtle. This is a very subtle concept. Yeah.
Mm-hmm.
I have one thing I want to insert real quick because it's a fear of humanity. This is a big fear next to fear of death. There's a fear they even did on the Big Bang Theory, that show, Warner Bros. And them. So here it is. People are afraid that the universe will burn itself out, that we're going to run. But they say that matter and energy coexist and they will never disappear. So how is the universe going to burn itself out, that we're in perpetual darkness at some point? They throw two things at us, that it's going to expand, that will be so gapped between things that we'll not have light anymore. And then they throw in, it sounds like a fairy tale. And then they have this thing that all the gases will burn out and we'll just have these little red dwarfs left or something.
We'll be a dead universe.
Yeah.
That's exactly the problem with the current physics and include biology. This is called the second law of thermodynamics. Seems like everything structure, everything order will eventually dissipated to disorder, to be garbage energy. And just like you said, hey, universe expanded so far away and then nothing existed. So, everything's lost, right? That's exactly wrong. So what I discovered, what happens? So actually, the everything's cycling. You see, star, transmitted, create a vibration explosion, right? And disintegrate into smaller particle, which I called into the fundamental form of a matter. That's a muon. That's a magnetic particle. And what happens when all the energy stopped? Explosion stopped. Slow down. Those magnetic particles, it has a force to attract themselves. They can attract themselves and assemble from the dust particle, assemble to be a bigger particle. So this is really a cycling motion. But in current theory, everything dissolved does not have any force. They said that gravity cannot make any two particle connect each other because it's too weak, right? So the current theory seems like everything dissolved, and eventually the universe will be no longer functioning like this one. That's not true, because every particles has a magnetic force. They were formed when the motion slowed down.
This has been a delight. Thank you so much, guys, for having me on this one with y'all, because this is just, I've been pulling my hair out watching these quantum physics programs, studying it. And it's like, I have one thing too, if they want to create fears, what about another Big Bang? If they believe in Big Bangs, what if another Big Bang happened in our universe? We'd be done. So why isn't anybody afraid of that? Why is it just a singular event, set, done, sealed, never going to happen again? If they really believe it happened, it could be another one, and then we're done. Nobody seems to talk about it.
Since Tom, you mentioned about this one, I just want to emphasize one thing, is the biology. Brian, you said that you studied chemistry, right? Do you familiar biology, evolutionary biology?
Absolutely, yeah. Biochemistry is my background.
Oh, biochemistry. Okay. So one thing about the mystery about biology, evolutionary biology, that's the top.
The chirality and the handedness of molecules.
Yes, the chirality, but they do not know how life started in the first place.
Right.
Because what they're missing the particle. Every single particle are magnetic particle. So when they disintegrate, they can combine them. When magnets combine them, they have a positive and negative. They do have a consciousness. You have a selection. Have a selection. Positive cannot combine with another positive. It push away and rotating. And when the structure comes, you have to have a coherent. structure. So that's what Stephen emphasized. So when you have a magnetic particle, which is a dipole, so it has to, in order to form, it has to have
Positive and
a coherent.
Right.
Yes, it's coherent. You have a selection coherent. That's where life originated from life, and that's where consciousness.
And if I may, there's a whole problem with conventional standard physics models is that it doesn't understand the layer of the concept of multidimensionality. Once you understand multidimensionality and you have other dimensions that you can originate force or even life force, whatever you want, from a higher to a lower dimension, and you conceptualize this as a lower dimension from a higher dimension, it gets away from, oh, there's nothing and then we're here. It's no, there's other dimensions. We're just the latest manifestation from higher dimensions tunneling down.
That's what I've been talking about. They must be pulling their hair out and seeing us all together, because it's like, this is what bring people together like this. I mean, the rest of the world seems to be about competition, being fame, legacy, getting their name down on something. They don't care about really genuine open thinking. So Brian's talking about layered thinking. I talk about layered thinking. It's like, possibly receded from other universes. It'll be nice to get a think tank together of good people like yourselves, and there's no holds bar, and let's just free flow. Wrong answer.
I do want to mention one thing. The Big Bang Theory would not work without
Penny.
Sheldon.
I see what you did.
Penny.
Sheldon.
Penny.
Sheldon.
Penny.
Sheldon.
Penny.
Sheldon.
Penny.
What do you want?
just saying.
That's entertaining. If I can make one more point, since Thomas mentioned about it, because we have this medium, right? The medium can transmit a light. Medium means made by real magnetic particles, which I call the Yuan. A magnetic particle you can infinitely divide. So there's not violated any law, and that's the only particle you can infinitely divide. Can be infinitely small. And so the so-called wave or medium is all made by smaller magnetic particle come out of this medium, just like a water, ocean. Ocean made by seawater, right? Seawater made by water molecule made by oxygen and hydrogen. If you divide smaller, so the so-called any wave is actually have a matter medium, right? So
instead of dividing all the way down by charge, positive or negative, you're dividing all the way down by magnetic polarity.
Both polarity.
And also coherency.
Coherent, yes, that's where you have a coherence. And none of the quantum mechanical particle, positive electron, negative electron, or positive proton, if you divide them, entire quantum mechanics model cannot exist. Because if you divide the electron negative charge particle, what happens? You have two negative half electron. Can you recombine them together? You cannot, because like charge repel. That's a fundamental law of Coulomb's law, right?
But magnetically it would work if you applied it magnetically.
Even magnets, any magnets you split, you will get another smaller magnets.
Right.
So that's
another whole unit. It's another, even if you split a magnet, you still get two whole magnets.
Yes.
Dr. you are going to allow a lot of intellectuals to get off of Xanax. And have peace and anxiety and give them hope. So thank you so much for presenting a viable view of what our universe really is.
I should thank Penny. You bring the great mind here. Everybody, so you see how eloquent Brian is, right? How deep thoughts, thinking Thomas is, right? I don't even need the explanation. And so, my ex-colleague, Stephen can, and June, you can explain for me. I'm so happy. How much time do we have now?
Well, I think we've come to the end of this segment. Next segment will be a little bit more prepared. We'll have some of your videos. Stephen. Okay, I get it.
I'm prepared.
We're never
Yes,
prepared.
I'm making sure you get the whole PowerPoint slide.
Yes,
It's
yes,
it's almost 300 megabytes. So that's why
yeah.
you send it to your cell phone. It's not going to work.
Well, that's all
Yeah.
right, Doctor. I have some like Dropbox, etc. So some of my presentations are a couple of gigs.
Oh, okay. So you understand better.
Yes, I
Yes,
do.
yes.
But I think this team is excellent. I'm very happy with Brian Singh and with Steven Sanchez and Joan Renee and Tom Althouse, and I'll just provide the comedy. So thank you so very much for joining us. Doctor, can you tell people where they can find you?
Oh, I do not have my own website, but right now I use my X files. That's at real real Dr. U.
Nice.
At
And
real
Dr.
DRYU. Yes.
Okay. And then Steven Sanchez, how can people get in touch with you? Can they email you?
Yeah, they can email me right now. I do have a website I've been trying to put up, backward engineering, but I got to get it online is what I got to do. But anyway, you can reach me at my email. It's the number 1 and then one word, goldentiger@gmail.com.
Excellent. And Brian Singh, where can people get in touch with you?
Yeah, either my email, Brian_Sang@yahoo.com, spelled just like on the screen here, TSENG, or on Facebook. You can find me Brian Sang, and then add my name SolarBee, and then please send me a direct message. And don't send me a direct message. Just say, "Oh, hi, you're great." I mean, that's nice too.
I know.
But I'm more goal oriented. If if you have a testimony to share, or you want to support the movement, or you want to get involved with the next events, please let me know.
Yes, and also if you want to be on Brian Singh's Presents also, and this is actually part of it as well with Dr. Weeping You, Universe of Dr. You. Joan Renee, where can people find you?
Well, you can find me here on Agent X11. You can find me on Trauma Triage on Wednesdays, and on Tuesdays and Thursdays, you can find me on the David Zubik channel on the Wake Nation, and on X, you can find me in Joan Renee 27.
And Tom Althouse, the real author of The Matrix. Where can people find you?
TomAlthouse.com. That was made easy for me. And then also 99 Justice the Facts. It's a joke. 99 Justice the Facts @gmail.com. You can message me there.
Excellent. And my name is Penny Ellis Shepherd. You can find me on X at Shepherd Out. If you would like to be a guest on Agent X11 or on the Trauma Triage team or on the Awake Nation, like Brian said, please text my phone, but say who you are, your first and your last name, and why you think you would be a good guest. And I will put you in my contacts, and then I will text you immediately after that. Please join us for our main show, which is the Awake Nation on the David Zubik channel on Rumble. We are live 6 a.m. to 10 a.m., and that is Eastern time. And I thank you so very much for joining us. Please like, share, and subscribe. We are out of time, so we are out of here. Shepherd out.
Saying out. Solar be out.
Renee out. Oh, well.
Steven. You guys are still here. And Doctor.
Okay. See you next time. Thank you.
Okay, then. All right, here we go. Goodbye for today from Agent X11, Hollywood Dark Journalist. We post new episodes daily. Check out our true crime episodes Wednesdays and Fridays. Please watch our main show, David Zubik's Awake Nation, on the David Zubik channel on Rumble. We are live Monday through Friday, 6 a.m. to 10 a.m. Eastern.